Okay, this module is module number 2, and it's Invoking MOCA services. In this module, we're going to be talking about the basics for forming commands. We're going to have the first discussion of what we call MOCA secret weapon, which is context, which is something that's very unique to architectures. We're going to talk about the data stream, normalize context, and show examples of how it works. We're going to have exercises at the end of this very quickly that we can run through, and hopefully we'll get some questions out of that. And in the end, you should be able to understand how to invoke any command, understand how to pass data to the components, and have an understanding of context. So let's get right into it. We, very early on, again, when we talk about the idea of accessibility, we had to make some decisions about how we were going to go about invoking commands. Now, keep in mind that this was a few years ago we came up with this idea. Everything was API based, so application-oriented interfaces, so programming interface based. Well, what we thought was that is a big limiting factor in terms of accessibility. If you said, okay, you have to be operating inside a programming language to activate a command or activate a component, it limits how many people thought they could get in there and do something, right? I mean, if we basically said you got to, like in the old world, you would say, oh yeah, no, it's easy. Just go into C, write this function, make sure you don't screw it up and blow your brains out, blow memory up, and no, it'll be fine. That's basically how things work. So we said, no. What we want to do is we want to make it more accessible. So we came up with this idea of having this MSQL. No, MSQL itself started off not so much as a programming language, but just an invocation mechanism. And now it's really developed into quite a thing, and we'll talk about constructs and things. But it can actually execute any ANSI SQL statement if you put the square brackets around it. So it's any SQL statement plus any component calls. So it really allows you to kind of go in and out of SQL and components. And actually, the coolest thing about it is mix them together. So a component request consists of two distinct elements: a command name and statement qualifiers. So I want to do this, and here's the arguments I'm passing. So we came up with this idea of having this verb-noun clause construct. Essentially, if you think about it, the verb-noun clause construct is exactly the way SQL works, right? Select something, right? Insert something. It's very kind of action-oriented. And if you look at the vast majority of the component calls in our system, they're very action-oriented, right? Move. How can you be much more action-oriented than that? Move, inventory, So it's very action-oriented. So verb, move, inventory, noun, okay? And the noun we say is, it's not just a noun, it's a noun clause. So you can say, list inventory for workstations, or whatever. You can actually make the noun clause fairly descriptive. And we wanted to actually have pretty natural language kind of commands, because if you said to somebody in a warehouse, oh, I need to allocate that inventory, they would say, okay, I know what that is. I need to move this inventory. I need to print a label. There are very distinct verbs that we use for things. While I fully endorse creativity, I would say if you're making a new component up, think about what you're doing and see if there's a verb that kind of matches what we're already doing, right? I actually, a few years ago, went on the verb reduction crusade because there was way too many different things, and I was starting to not understand what people were trying to do. So look at what verbs are out there. Try and stay away from SQL, constructs. I don't like to see, I do see this from time to time, a verb called insert. Okay, fine, it's fine, it'll work. Okay, do I like to see it? No. I think it again, as far as accessibility, it just makes things a little confusing. I would like you to use something like get or list or something that is not a SQL word. Will it work? Yes. Will you get some eyebrows? Yeah, probably. We have these constructs, and we try to make them as simple as possible. Statement qualifiers, passes the arguments on. This is in the form of name value pairs in the form of a where clause. So command name, where, this equals that, and this equals that, and this equals that, and this equals that. That's how it works. So it's just like a where clause. It is, in fact, a where clause. We actually will parse it like a where clause. So now the thing about MOCA and discrete is this. Everything has a particular name. And we'll get to context in a minute. MOCA will be very confused about something if you start using names for things they aren't. Okay? We think a storage location, a stoloc, is always a stoloc. When MOCA sees a stoloc, it says, hey, it's a stoloc. If you use the word stoloc, it's got to be a stoloc. Okay? You cannot be using names of things. So if you do select column as, so you can make an alias for a column, okay? Absolutely fair. But do not do something like select load num space stoloc. Okay? Things are going to get very confusing. Okay, I'm not saying you would do that. It doesn't make any sense. But I always have this, oh, I want to call it this. All right. I don't think it's that, but okay, there's a couple of instances inside MOCA where this is not true. Actually, it's not inside MOCA, it's inside DCS. And this is a little bit of a bane in our existence, frankly, when you get on the shipping dock, and it's docnum. Docnum is a little bit of a pain in the butt because docnum exists on 3 tables. Shipment, stop, and carrier move. So let me ask you, if I say docnum equals this, what am I talking about? I don't know. I have no idea. Okay, so this is one of those things where, out of zillions of things that we did right, this is one of the few things that we screwed up when we did the data model for the shipments back about 1999. We did not do this right. Now, there are other components or other fields that are the same on tables, okay? But they are not significant to processing typically, like insert date, last update, that sort of thing. Now, what it will stop you to do, try this for a second and in fact, I might have this as one of the exercises. Do a list inventory where load num equals 1, 2, 3, whatever load num. Pipe that to list inventory. Okay, one would think that would work, right? Because it's just taking all the arguments from list inventory and sending it into another list inventory component. Will it work? No, it won't, because it doesn't know how to deal with these dates that are the same on every single table that it's hitting. So what it'll do is what MOCA does is it takes like the first one it sees. So if you have multiple columns that are named the same in a result set, you will only see one of them. MOCA will only return you one of them, right? Because when it makes its result set, it's basically saying, give me the distinct elements to create a result set. So in this case, it's taken let's just take one of these, last update date. Which table is it taken from? I don't know. But in any case, it's going to fail to select because last update date is not the same for every single item in the inventory load, inventory sub, and inventory detail tables. So be aware that, first of all, I don't like using list inventory piped to anything. Okay, just so you know, I do not like that. So people come up to, I'm doing list inventory, and then I'm removing all these things from context, and then I'm passing it into. You know what? Don't do that. List inventory is very handy for listing inventory. Not so much when you're piping it to things, because what happens then is somebody puts a trigger on something that you're doing your list inventory, and then you got a whole bunch of other stuff, and you got tons of data in context. It's not a good idea, right? So that's just a little commentary on list inventory. Some of the things that we do here on the statement qualifiers, we allow you to do aliasing, and you'll see this in the command definitions. Aliasing is done for two reasons. One is we like the idea, and the original concept of aliasing was to say, if you're doing natural language stuff, it'd be nice to not have to know every single variable in our system. Like stoloc is storage location. TBL NAM is mostly table name. So we created this so you could say, well, TBL NAM or table. Okay, you can either one. We'll use that. So that's one way to make it more natural. The more important way of looking at that is an opportunity to understand contextually what is going on. Stoloc. Stoloc is a stoloc until something's in motion. Stoloc is only a stoloc while something's sitting there. A stoloc becomes a source loc, and a stoloc becomes a dest loc when things are in motion. Right? Okay, so we have this idea of being able to switch contexts depending on how things are being called. So, it could be a stoloc or a source loc or something like that. So we do a little bit of that. Or it's a load num. It could be a source load if you're in motion. So there's some things like that we do there that allow us to use aliases. So two reasons for the alias. Some simple component calls like list devices. Probably equates to something like let's select asterisk from devmaster. So why bother? Okay, why bother? I mean, it's a simple thing. You could just put a select asterisk from devmaster instead of the list devices. Well, ultimately what we want to do is we want to shield the caller from the implementation, because a year from now we're going to add like 5 things onto the device master field or device master table, and we might do some things where instead of just doing a select from we might go and join to description stuff. And okay, we want to shield folks from that level of understanding of the data tables. So when somebody says list me the devices, okay, there you go. Now what is that doing to get that? Not so much, not so important that you really know that. The most important thing, and the thing about a SOA, a services-oriented architecture, one of the most big value items is that you should be, as the caller of an argument, what we call a consumer, as the consumer of a service, you should not have to worry about the implementation, how the thing's written, how the component's written. You should just be worried about what you need and what it does, right? So ultimately, down the road, we can change the implementation totally underneath the covers. And if we do it right, nobody is the wiser, except that the system works better or the system does more, right? So that's the key. Even those simple things. So when you're writing components out there, doing your thing, okay, be nice, do components. Don't just shove them into SQL statements. Adding statement qualifiers, so that name value pair concept. So in this case, list devices where dev code equals my dev. And then you start adding more things. And so it's just like a where clause. Where, and then it is exactly like a where clause. Again, why we did it, simple, easy to understand. One of the constituents that we have to deal with as folks that are the implementers of these systems is the IT staff that is going to ultimately take on more responsibility when we leave. Okay, so having a construct like this makes it very understandable to folks that, frankly, are way overworked, right? They got no ability to take on anything else that they need to learn, right? So if you give them something and say, hey, it's just SQL, it's just a where clause, instantly, frankly, in the sales cycle too, it helps us a little on the sales cycle because, it is again, it goes to our empowering idea, and we take it seriously. So, this empowers the folks that are going to be taking on responsibility to say, hey, man, this is not such a big deal to understand what's going on here. So we're going to spend the rest of this module and the next 2 modules talking about context and how to use it when developing and working with componentry. So the idea of context is the main thing that differentiates MOCA from any other architecture. Context is what allows MOCA to bring state to stateless components. Context exists in memory for the lifetime of the client to MOCA transaction, what we call the command stream. Okay, command stream starts by the client, so that client could just be somebody typing in MSQL from WinMSQL. Starts when that client basically starts at the first select and ends at the very last thing. That whole thing could be a ton of different things going on. We call that the command stream. Okay? That's the start of context, is the very first command. The end of context is the very last command. And context affects things that you don't see, triggers, wrappers. Think of context as a rectangular data set that can be linked iteratively, and we'll talk a lot more about that. So here's the concepts that we're going to talk about, and I'm very good about using this language consistently. Command stream refers to a stream of commands that are tied together by pipes or command separators. So in this case, select load num from INV load, pipe that to allocate inventory. So here we're introducing one of the first concepts, the pipe, the command separators. The pipe and the command separators allows us to basically take one command and redirect the output of that command into another command. Publishing data. Publishing data is the process of making data available downstream. Okay, so stream goes, select load from INV load, pass going downstream means it's going that way into the next component down, the next component down, the next component. So when we talk about downstream, we're talking about subsequent commands executing. SQL statements automatically publish their data. Okay, SQL statements automatically contribute data to the context. Where clause, essentially, a where clause publishes its data to the components it's being sent into. So that's the first part of context is the where clause. Okay, so that's the first, think of a where clause. It is a rectangular data set, right? Okay, it's a very, scrunched down one, but it is a rectangular data set. It's name value pairs, right? One row, bunch of columns. Published data is one of the things that we added several years ago in our effort to try and make it possible for people to do as much with MOCA while not having to write C code or lower level language code. Why? Because my opinion is people who don't code in C often should not code in C at all. Okay. Now you will need to from time to time code in C, and why? Not because I have disrespect for people that don't code in C. For instance, I would have loved it if I would have made it through my life without writing one line of C code. I would not missed it at all. But C is a very temperamental little beast. I mean, it is very precise about things like memory management and pointer arithmetic. And if you're not grooving on the idea of memory management and pointer arithmetic, there will be problems. So we did things, for instance, we'll get to in a subsequent module. The whole way that we do RF programming was because we used to do C code to do all those RF programs, and stuff was popping, sizzling all over the place. Okay, the more we can raise this so that folks do not have to write C code or, frankly, Java or whatever else, the easier it's going to be for everybody to do the implementations. Puts a lot of pressure on MOCA to do its thing right. So one of the things that we needed to do is we needed to say, hey, we need to be able to contrive contort context. So published data allows you to very specifically get in there and say, oh, I'm not just going to, we used to do it by just doing a select from dual or whatever, you know, it would, because SQL statements automatically publish. Published data allows you to do that same thing, but without making a round trip to the database server to do it. A data stream refers to all the data that's live in the command stream. So we'll talk about the data stream and the context or context level, or sometimes we call it normalized context when we send it off to a remote command. That refers to the data that's seen for execution within the data stream. So it's relevant to whatever executing next. So here we have a simple little move component. Move inventory, where load num equals 1, 2, 3, desc loc equals ship. So the load num and desc loc creates the initial context for this component to operate. This would be similar to saying publish data where load num equals 1, 2, 3, desc loc equals ship, pipe, move inventory. All right? They are essentially the same thing. There are instances where you'll need to use this. For instance, we'll get to this in the release section. Release rules. In the release rules, the where workref equals is just lobbed on to the end of your component. Where workref equals. Okay, so if you try and put a command in there that has a where clause already, it's not going to work because it just arbitrarily tosses the where clause right at the end, without regard to whether there's a where clause already. So one of the things that we typically do in there is if you have to publish data, if you have to create arguments, other arguments, you're going to have to use this technique to do it. Right? So that's one of the few times where you will need to do that. Just handy little trick. Avoid you having to debug that the first time you do it. So here's what context looks like in memory. So what we've done here is we've said, all right, select load number from INV load and pipe that to allocate location. So in our new example here, select load num, pipe that to allocate location. So the first thing that happens is we create a result set of loads, right? And then what happens, so now we got this rectangular data set, starting with this rectangular data set called load nums. Boom, a bunch of them. And then what happens is we see that now that becomes the input to the next command downstream. So if there are multiple rows in that, you have instantly created a for each loop. Essentially, this creates a for each loop, right? So for each of these things that are in the result set, it's going to go ahead and then start iterating through the result set, calling all the commands that are downstream from it. So here we're going to say for each one of these guys, essentially what would happen is for those 10 loads or however many there are, we're going to call allocate location. And what MOCA will do then is as it's iterating through the data stream, it creates context, a context for each execution, right? Based on the current row that it's on, it'll grab the columns that it needs to supply for the next component downstream. So in this case, the only thing in the context that allocate needs is a load number. It could get more, yes. Minimum does it need is a load num. So in the end, what happens is it iterates through, and then that creates a result set. So again now, rectangular result set, boom, to another rectangular result set. So now in memory, okay, the data stream in memory has the loads, but also has whatever is published by allocate. So all those things are still in memory. So as I was indicating here on this slide, you can see it. We're going to parse our way through element by element. Okay, so we get that first result set. That causes us to start iterating. For each one of those, we're going to call allocate location. We're going to start constructing this downstream result set, this bigger result set down here that just says result, the published data that's coming out of this thing. Now let's look at a more complicated example. We're going to do the same thing. We're going to allocate these guys. So we're going to do a select load num from INV load where stoloc equals receiving, allocate a location. So we're going to basically grab all the pallets that are in receiving, allocate a location for it, and move them. Now, would you ever do this? No. I mean, you could, but it would really screw some things up. Because, moving things logically, the whole thing about our system is these systems is keeping the logical world and the physical world in sync, right? That's the hard part about our jobs, right? I mean, people doing banking stuff, there's no real physical stuff going on except if you're doing ATM software, right? Okay, it's all logical stuff. For us, it's physical, right? We're always keeping the physical world and the logical world in sync. So you would never do this in reality, right? You might do the first part of this, which is find everything in receiving and allocate a location for it. Put it out to the work queue, let somebody do it. But in this case, so what we're doing here is we're finding all the stuff in receiving, we're allocating locations for it, and then we're calling move inventory. Now, isn't it interesting that those allocate location and move inventory components don't need anything to be specified on them, the way we're calling this? So here's what we're actually doing. The first thing, the select returns a result set with load nums. Okay, and then we start iterating. We're going to call allocate location where load number equals 1, 2, 3. That returns a desc loc. Okay, what are the minimum requirements for move to work? A thing and a destination, right? So in this case, it's just going to go right into move, and it's going to say, hey, go ahead and move that. So it's essentially the same as saying move inventory where load number equals load 1, 2, 3, and desc loc equals 01A21. Right? So that's how these result sets populate. Now you can start to see the idea of context is that the lifetime of the data stream is really important, right? Because we're reaching back all the way to the results of that first select to grab the load num, right? But we're only reaching back one command to grab the desc loc. And so what MOCA does is it keeps the current row, okay, of every single piece of data in memory, right? So you could be iterating through, and it keeps all these pointers set correctly so that, if you're going to do this, we're going to grab the load number from this essentially context row and the desc loc from this context row. All right? So that's kind of the important thing to remember about context is that the data stream lives to create context. Think of context as kind of a single row of data elements that are your point in the data stream. Okay? You could be, if you think about, you've got this big rectangular data set here, you got a bunch of it basically slices through there and says, this is your context right now, right for this element. This is your context. This is what you see. You see nothing else. You can't see above, nor can you see below. This is your context. Boom, right across. So it essentially just looks like one big record to you. Some things about accepting variables. The @ sign pulls variable from context. So in this example, select star from local master for stoloc equals whatever, and select asterisk from area master where area code equals add area code. Sending data to context. Again, any select automatically publishes. Now the thing about selects is they not only publish, the difference between a select and a published data will always return one row. Select will return whatever you tell it to select. So when you create context with a select, you're not only creating columns, you're creating potentially rows of data. Okay, so here's select stoloc from locmast that publishes a stoloc, etc. Select one test from dual will basically select a one, call it, name it test, and send it into context. That's how we used to actually populate context until we had the publish data command. You actually will still see it in some cases where people do a publish data or select something from dual and name it something to get it into the context. That was probably written prior to getting the publish data command out there. Publish data is a more effective way to do it. One, because you know how many rows it's going to have, one, and two, because there's no database round trip required for it. That is completely within MOCA. And we'll go through a couple little different ways to handle the @ sign replacement. Publish data where @ plus means, if it's in context, it'll put it in there. That's very handy to do, especially as we get into subsequent modules, especially in situations where you're coming in and out of braces, in the curly braces. Transactional boundaries normally match context. Okay, so the data stream. So normally what happens is you send a big command, and normally your database context is going to match whatever that command is from start to end. There's a couple ways around that. We're going to go into that later. But normally when MOCA is handling the transaction, when we're not doing commits by ship ID for releasing, or we're not doing stuff in allocate because we don't want to lock the system up. Normally what will happen is it's very simple. If everything's okay, it commits. If something is wrong, it rolls back. Now anybody, any command, any component can raise an error and say, oh, whoa, hey, things are not right. So you could have moved, do all kinds of crazy stuff, and in the end you could have just a little trigger saying, yeah, not so much, and then roll the whole thing back. Okay, so it's important to understand that it's not only the component calls and the components that are there that could actually cause the thing to roll back, it's the invisible things, the triggers that you don't see when you're asking for the component to be called that could cause the rollback. So what happens is the first component or SQL statement encountering an untrapped non-zero value will terminate the transaction. Transaction is automatic. By the time you see it back, it's been rolled back. So no need to do a rollback unless you're doing something odd, like running in no commit mode, right? Which is not something we typically do. You might do it for testing, but never do it in production. So commits and rollbacks should never be. I just like to say that because then then some people say, well, you said never, and then they have to go to somebody and say, is it okay to do it here? Well, yeah, it might be, but let's just say never. I think we can agree on that. It should never really be part of a component. And I actually have examples where there are reasons to do it, but okay. So that's the deal with that. So from this exercise, we should be able to invoke some relatively simple to complex MOCA components. You should have a basic understanding of context, and you should understand how transactional boundaries work. So in this module, we're going to do some exercises. We're just going to do some basic selects. We're going to do some piping of data, and we're going to take a look at what context looks like in memory. And what I always like to tell people to do here is, if you really want to look at context, turn tracing on. Okay, tracing helps you understand what's going on with context because it shows you how things iterate. And now the next module, actually, we're going to go very specifically about how iterations work, because one of the things that's most misunderstood about MOCA is exactly how it iterates through data. And it's important to understand because it's not as obvious as you might think.